Okay, so we've looked at some input devices already. We looked at the potential divider and we've looked at potentiometers. We could also use switches as input devices. So switches are basically either a break in the circuit or not a break or nothing in the circuit. Okay, so if a switch is open or off, then you've just got a break in the circuit. So you've got really, really high resistance and nothing can flow through it. If a switch is closed, then it's basically just like another wire. Okay, so very, very low resistance. So this experiment, again, I'll show you a video of this experiment. So when we're looking at two different circuits here. So the top circuit here is we've got a resistor at the top and we've got a switch at the bottom, and we're measuring the voltage out across the switch at the bottom. So if the supply voltage is 6 volts, which it usually is, then when the switch is open, i.e. off, that means we've got a huge resistance. We've got a break in the circuit. So remember, the bigger the resistance, the bigger the supply voltage across it. So if you've got a huge resistance, then it will get all the voltage. So it will be 6 volts. But when it's closed, that means there's basically zero resistance across the switch. So if there's zero resistance, then it won't get any voltage across it. So you'd have 0 volts across it. Okay, if we look at the other circuit, this time around we've got the switch on the top and we've got the resistor at the bottom. So we've got again a supply voltage of 6 volts. So in this time, when the switch is open, there's a huge resistance across the switch. So that means all the voltage will be across the switch. We're actually looking now at the voltage across the resistor. So if all the voltage is across the switch, then there must be no voltage across the resistor. There's no voltage left over. So that's going to be 0 volts. And when it's closed, that means there's basically 0 volts across the switch. So all the voltage must be across the resistor this time round. So 6 volts. So in conclusion, in a series circuit, the higher resistor gets the biggest share of the supply voltage. When the switch is open, the resistance across the switch is very high, and so the voltage across the switch is high. It's pretty much all the voltage, it gets all the voltage. When the switch is closed, the resistance across the switch is very low, and so the voltage across the switch is low, pretty much 0. A switch can therefore be used as a digital input device given a voltage dependent on its state, open or closed. So either if the switch is open, it will get all of the voltage across it, so there will be 0 volts across anything else. But if the switch is the switch is open, it will get 0 volts. Sorry, scratch that. If the switch is closed, it will get 0 volts, so the voltage will go elsewhere. If the switch is open, it will get all the volts, so anything else will get 0 volts. Right, getting a bit tongue-tied there. Okay, I'm going to stop that there and let you watch the video of the practical, and then we'll move on.